This video is partially sponsored by Element 14, an AVNet company. This is a road test, and I was able to receive both systems for free for evaluation purposes. Thank you to Element 14 for selecting me, and let's get on to the video. PSoC 4100T Plus is a low-cost ARM Cortex-M0 Plus CPU using 5th Gen CapSense with multi-sense technology. Its core speed is 48 MHz. It has a very wide operating voltage from 1.71 volts to 5.5 volts. Comes with several standard peripherals such as PWM and UART. It includes one 12-bit 1 megasample per second ADC, and it has up to 128 kilobytes flash and up to 32 kilobytes of SRAM. This is their latest touch sensor microcontroller. It is a very cheap one, and it comes in a variety of packages as well. You can get both of these boxes if you wanted. The prototyping kit with all of the sensors included is $19.74 American, and the actual microcontroller that we're using right now is $19.97 American. So grand total of $39.71 US. We have some microcontrollers to examine. So first things first, I have a PSoC 4100T CapSense prototyping kit. This is an Infineon microcontroller with some extra touch sensors and another header so I can attach more. What I also received for this road test for evaluation is this box here. The box, unfortunately, seems to be beat up from the packaging. If you can see that, there's some damage, shall we say. So we're gonna open these things up and we're going to see what we got and what I will be evaluating. So first things first, let's do this microcontroller. Well, it's definitely holy crap. Well, at least it's secure. Alright, let's see here. So we first have the PSoC rocks. We have this microcontroller. Definitely much smaller than I thought it was going to be, but it's alright. Strange though is just how thin it is with everything, and definitely a problem that I will definitely say is these connections. Let me get a close-up on here. There we go. You see, this top one is connected by only these 4 little pegs. I see traces in them. There are some traces, and then this one down here has a few more pegs, if you will, to connect it. But this is, it's not flimsy, it's very sturdy. And I can see the tempered glass on the microcontroller, so that's definitely a good sign. So I know that I at least have the right sensors, but it's kind of odd seeing how weak it is. I mean, even the USB here is connected via some very small connections. So gotta take a lot of time to ensure you don't break things, that you don't snap it or anything. So while it's a very slim and nice design, it definitely does not seem the most secure and the most stable. So that's the microcontroller. And we also have this this thing. Let me see here. What is this thing? Does it actually say what this thing is? No, I do not know what this thing is. So when I actually, though, am able to tell you what it is, I will. Because right now it kind of just looks like it's
Oh, maybe this... Oh, hang on. I think this is another one of these glass sensors here that are actually for the touching. Maybe it goes down here? I'm not sure. I will look into the instructions and I will let you all know. So, what we can see here is a nice detailed description of everything that we get. So, USB-C connections, some buttons, capacitive touch, proximity sensors, connection header, LEDs. So this is a nice big containment of touch sensors for several different applications. So it seems like it's a nicely powerful system if it can handle all that. Then let's open up this box. This box has some magnets to keep it closed, but unfortunately nothing to protect it against damage. But here is the kit or everything that should come in the kit. So I have a bottle for liquids because this thing has a liquid sensor here. So I'm guessing that this will tell me how much liquid is in something. So if I filled up this bottle with water, then I would expect that I would be able to say, hey, I have an excess amount milliliters of water or something. Interesting. So I have that. I have a 4-touch board here with some LEDs as well that will actually light up when I press on one of the sensors here. And then I have the same thing, but it is a 2-button version instead of 4. Again, your header here, you connect it directly into the microcontroller, you power it up, and then boom, you get your applications to run once you flash everything. There's also this, another capacitive hover sensor or touch sensor. So hover over one of these buttons and then your LED will light up. So in case you're wondering what a resistive sensor is versus a capacitive sensor, capacitive means that if you hold your finger close enough to the button, it will actually activate. If you hold it far away, it won't. But the closer you get, the more the ability the capacitive sensor will be able to actually read your incoming press. Resistive, which I will actually be demonstrating on another screen that I have, is you have to touch it. You have to create some pressure on the screen in order to actually activate the pressure sensors inside. So capacitive, you can just lightly tap and it will be done. Resistive, you actually need to press down like on a phone from an older generation, or like you're pressing a key on a keyboard. Then I also have USB cable, very standard USB-C cable. And then there's also this other microcontroller. So this is the PSoC 4000. This one here is the PSoC 4100. So you can see the difference in both the size and everything that is attached to them. And notice they both have jumpers. This one here with the blue jumper, it doesn't look exactly even. It looks like it's kind of tilting to the right a little bit. It's not a big deal. It's just my preference to have everything lined up. I might just be seeing things, but it definitely does seem like it's just kind of leaning over to one side. So for this road test, I was told that I don't actually need to test out this board. I may test it out just to compare it to how it is versus its newer generation. So this is all the equipment I have that I was sent. I'm going to start setting up everything and get all the software installed, and then we're going to see just how accurate these touch sensors are. So let's head on over to Le Computer and install some software. Alright, let's plug this thing in and see what happens. So, standard USB cable here. Plug it in. And then plug it into computer. Ooh, pretty. Let's get some focus. Alright, so we have, looks like a power LED, we have, it looks like a user LED, and the sensor board comes equipped already with all of the touch sensors and everything already pre-established, so all of the software to use everything is already on. So if I start going on here, ooh. So the touchpad here has a detection sensor in it as well, so it can see when I'm coming at it. So there's a hover sensor on it. And it also has the 4 LEDs change their actual brightness when I am going around. So if I'm in this corner here, it's going to brighten up those LEDs more. So the LEDs essentially track your position on the trackpad. Interesting. Not the most accurate, but it seems as though it is indeed doing the job on the bottom here. Let's move up here to the top. This is another hover sensor. A little inaccurate, unless let me see if I can. Maybe this is just the touch sensor. Oh, this is a button. I guess I got thrown off with the H. Let's see here, then this button here. Alright, so that button is indeed working. Let me just make sure. So, let's get everything in line here. So, 11 is the ambient light sensor. So right here is an ambient light sensor. So this thing here will determine how much light is in the system, and I guess that this LED down here is the one that actually determines that. So the ambient light sensor seems to be working well. 12 is just, this is just a button to determine if it's being pressed or not. This is also a button which turns on the other LED. Now it seems as though there is stuff on the back as well. So if I try and touch things on the back, then it also lights up. So it seems as though there are sensors on both sides. So it's not just the glass area. So everything here does indeed have sensors on both sides of the board. It's not just like on your phone where only one side is touching and the other side is just the back. So it's kind of like a PS Vita, if you remember those, where you have the touch screen on the front and then you also have a trackpad on the back. It's kind of an interesting thing. Now, Infineon does have a modest toolbox, and that is the actual software that we use to program this microcontroller. So, I'm going to start setting that up now, and we'll get going with trying to program some things in. Alright, let's install the needed IDE for this microcontroller. So, it should be modulus at Infineon. Alright. What is toolbox? It's just not the automotive one. I need the toolbox.
Alright. Let's go through this. And let's download the software. Waiting for user interaction. Well, I am clicking. I need to touch the controller. I'm not sure what it actually is asking for. Oh, I need to log in. Alright, 1 second and I will be right back. Alright, now that I have everything done, I have downloaded the file. Let's just go through it. Quick installation's just fine. Yes. Alright. Let's open everything up and see what's going on. Alright, just useful information, not really needed. Close it down. Alright. Default Modulus Toolbox installation. And I have to log in again. Okay. Alright. Now, wow, there is a lot of stuff that they have, a lot of updates. So everything here is going to be installed. Let's see what's going to, how big this is and everything. This is going to probably take some time. So, let's have some more fun with the microcontroller while we wait. Alright, so as you can see from right now, I haven't touched the microcontroller and the user LEDs have all gone off right now. So when I actually get closer to the sensors, then the LEDs start coming back up. If I hit the reset switch, obviously the system resets. The user button, if I can manage to not trigger a proximity sensor, somehow, some way maybe. The user button right now really doesn't do anything. But I have learned actually that there is something we can do here with the mode button. So give me 1 second and I am going to then demonstrate what happens when I press the mode button. Alright, so when I press the mode button, you can see the LED starts to flash there. And then what it actually does is it brings up, I'm guessing these little documents here, essentially saying everything that's right now on the microcontroller. So it has all the security codes and all the links and IDs of the microcontroller right now, I'm guessing, and a bunch of other things. I'm going to see if I can find some documentation to actually explain what all of this stuff is. But now if I actually go to this URL right here, it is going to do nothing. Hang on. It is going to bring up an ARM embedded page. So on the microcontroller, it actually has a small, I guess a little local server that has a folder on it that brings you to a list of all sorts of controllers, not all from Infineon, but all that have ARM embed enabled microcontrollers, or at least the majority of them have the label on them. So, not a very interesting website, and definitely not something that's needed, especially since the embed program is going to be end of life by middle of this year, so it kind of seems irrelevant to have it now, but whatever, it's okay. So close this down, and then I press the mode button again, and it goes then back to normal operation. Now I can still, as you saw before, I can still use the microcontroller as is when it's in that let me share with you the folder mode. So it's kind of interesting, everything that's on here. So I'm going to stop the recording right now, and I'm going to let this thing finish installing. Alright, the IDE has finished installing. It took about 15-20 minutes. Let's see if we create a new application. Hopefully the board is detected, and the board is detected. What I see here is just an overview of everything. What the kit contents does not actually include is the 3mm additional overlay for the touch pad. So not that important really, it's just an extra one, it's not truly needed. So let's go next. See what else we can do here. Can do some basic classes, loopbacks, bunch of peripherals, sensing. The demo is most likely what is already on board. Here are for some of the other sensors. So I'm guessing then that to actually use everything that was in the other box, I would need to use some of the other templates here. So let's do the 2pad first. New application name, I'll just leave it as default. Let's create. There's a lot of things it has to do in order to actually get it. I thought it would all have been installed already, but it is going crazy right now, updating everything. Any day now. Alright, I will come back once this is all done. Alright, it is now finally finished with all of its updates. There are a lot of instructions and a lot of different setups here. So, let's see here, using create. Alright, so I'm going to be using these 2pad connector, so I'm going to set that up real quick and be right back. Alright, now it is time to begin our first real programming experience with the PSoC 4100 and the 2-button board, which also has 2 pads on it on the back here. So it seems as though you could use it either way. These are coils, so I'm guessing these are resistive coils, and then you have the actual capacitive touch pads here. So let's plug this in. Very tight, but it's good. It's nice and secure then. Then go to the design here. It's a lot of information, and it's also somewhat cramped. I wish I could zoom out. This is, I'm assuming, find. Yeah. So. Alright, so we see here 2-pad board. This is the Eclipse IDE. So Project Explorer. Here is the main file. So this is the C file that everything's based off of. With your PC. Okay, so this here. So it looks as though simple. All I have to do is just set it up and debug. And then this also goes through all of the tuning and seeing how everything is doing visually. I'm going to do this a little bit later. For right now, we're just going to make sure that all of the sensors work. So, first things first, go over to the main C. I will plug the board in, let it boot up and everything. And then, let's see here, run. Alright. I'm assuming this will have no problems, but let's build it anyways. Alright, one warning, but I'm not going to worry about that because it's most likely just something that is already done. Oh, yeah, not going to worry about that. Alright, now let's debug, or actually, let's run it, not debug. Okay, let's see here. Configure. It would probably be this, I would imagine. It's probably using J-Link. Project, yes. Debugger. Startup. Let's see here. How do we run here? Do launch configuration prototype maybe? It's not exactly as straightforward as I would like it to be. Search project. Alright, so the ELF file is in. Now, we still can't run it. Debugger, device name. You want a name for it. Well, when in doubt, this is why they invented Google. let's see here. As you can see, I haven't pre-done any of this stuff. I want to give the full experience doing it right here, right now. So, modulus, what's it called? Modus Toolbox. Modus Toolbox run script. I guess I should say in Eclipse. Eclipse. Oh, it uses CLI? It uses the terminal? Hang on, let's make sure of this. Program, let's go to program. Alright, build application. You did that. Import, no, where is run? Modify, no. Let me find out where I need to be. Where is it? Where is running? Build. We've built. Program and debug. Oh, duh. It probably would have been better if I just went straight to this. Okay. Launch configurations. Alright, I need to go here and this. Okay. Now, let's run. Uh-oh. Does not exist. Interesting. All right, let's go back. Let's try running again. Oh, it doesn't bring up that. Let's see here. Yeah, okay, here we go. program. This should exist, I would imagine. Command not found. Okay, I'm going to actually stop the video right now and try and figure this out. So, be back in a minute.
One eternity later.
Oh, right. So, it's been quite some time since I recorded, simply because I couldn't figure out how to program in the microcontroller. But fortunately, I was able to eventually figure it out thanks to help from Infineon. Apparently, starting from their IDE version 3.5, I believe, and on, they actually removed the debugger. So you can't program the device natively from the Eclipse IDE, which definitely does suck, and I wasn't aware of that. It also really wasn't made clear on the download page. I mean, I didn't see anything, and there was no warnings about that. I didn't see anything about installing it either when I actually, tried to install it. So it's definitely weird that they wouldn't mention that. I mean, if you just buy something, you would imagine they would at least tell you what you need. So you download a separate programmer, and then you will change the path in the run configurations. So when you actually go and you try and debug, you'll have to find the actual executable for debugging. And then when you actually find the executable, then it will actually turn on and everything and program the board. So let me plug in the board. Alright, there we go. And now I will run the code. And now, unlike before, I should be able to have everything work. Alright, and now I do believe that the board is programmed. So these two buttons up here, they aren't exactly what I thought, because if you notice, I can tap the button but nothing really happens. I really have to push down on the button to turn them on, which isn't really good. I mean, it's a lot of force. Even a resistive touchscreen that you could use that you could just buy isn't nearly as hard as it is to push these down. I mean, I could activate a resistive touchscreen just by this. But this is also an inductive keypad, which means then that on the bottom here, there are these actual circles here that, hang on, let me just focus. There are these circle pads here, and if you actually touch them without actually, without what their intended use is, the light stays on. You are essentially glitching the board when you touch these two back buttons. And so these lights will actually stay on no matter what then. But if you, push real hard or you touch back here, then the board kind of glitches out a bit and the lights behave erratically. So to fix this then, reset the board. So then, if that's not the way you activate the lights on the back, what are you supposed to do? Well, inductors are actually good for electric fields. And so, what I can do is I can take a piece of metal
such as USB cable here, USB cable, and I can just bring it close and notice how it turns the light on very easily. That's because it's detecting the metal. So the inductive keypads here are actually detecting metal nearby. The problem though is that I still don't actually have anything here. So it makes me wonder, are these buttons here actually buttons or not? Because they don't detect the metal on that side, but they do on the bottom side. So it's definitely, how do we know then what these two are? Because if you look at the instructions, it doesn't really say what the buttons are. They're just they're just the inductive touch over metal button. So it really doesn't say much about the point of what it is though for the top. Because you can detect the metal on the bottom very easily, but you cannot detect the metal on the top, but they are more like push buttons on the top. So it's definitely a strange aspect of this one board. But that's just this one board, and so I'm going to then disconnect the device right now, so I can then, oh, hang on, I gotta actually stop the debugger. That's always a smart thing to do. I really should be doing that. Now I can eject, and now I'm going to replace the two buttons. Oh wow, this is quite warm actually. Not too hot, but it's definitely warm. With the 4-pad. So with this. And if my theory is correct, this is just double the amount of keys as that. So plug it in. Now I can plug the board back in to the computer. It takes a bit of time when I'm using an extension, it seems, which is kind of strange, but whatever. Alright, so right now, by default, buttons 3 and 4 seem to be hooking up to the board. But of course, that's not really what I need right now. So I'm going to go here, File, Project actually. Wait, no, hang on. I've done this before. I can do this again. Like I said, it's been some time since I did this, since I could not figure out how to actually create a way to debug. So, hang on, Project. No, hang on. I can do this. I know I can do this. Source, edit, import. No, that's not right. New. Oh, I just have to do new Modbox application. Okay. There we go. So, select the board. Next, sensing. We need the 4 keypad, right? Yeah, I'm pretty sure. That's exactly what we need. And then this one. Create. Alright. And then when this is done, I'll just briefly go over the debugger for you. This is definitely a much bigger project, as you might expect, because it's 4 instead of just 2. Alright, this is going to take some time, it seems, so I'm going to stop the recording and be right back when it's all done. So as promised, I'm going to now show you how to actually take care of the changing executable. So, let's just say I open up the debugger, and this was the initial executable path. Well, this is not right. So, what we actually need is, and so I didn't need to remember it, is we needed this executable path, the open OCD underscore path / open OCD executable. This is what is actually used to program the device. And if I was to go to my desktop screen, it would be this program right here. So this is what I needed to install separately to actually begin programming in the board. Now, once I actually created the link to this executable, for some reason the shortcut executable on my desktop just disappeared. So I can't actually run it from here. I can do it if I go into the location in the file manager. I can execute it from there, but I can't do it normally just by double clicking on that. So now, this is how you have the executable then. So I will close that down. This is the demo for the 4 button. Let me just set it back up again, 1 second. Alright, system plugging in. As we can see here in this README, it gives us a good sense of everything that we can expect here. Now, of course, just like before, this is using the smaller module. This is using the 4000T, whereas the board that I'm using right now and I'm demonstrating with is the 4100T. But it should work the same thing because it's based off of the same architecture. That's why the code can work the same despite the fact that it's a different board. So let's just make sure then that everything is working as intended. So I will hit the run button. Well, first I should probably build it, perhaps, maybe. Oh. Okay. It's just a little slow. Okay. Alright, so now let's see here. Does it work? Interesting. I don't think I actually programmed it correctly. Hang on. Let me try doing this again. Let's try debugging it. First, let's stop. Stop the connection to it. And now, let's do debug configurations. Alright, it is set to the executable. And now, let's hit debug. What the? Did I not select the right Did I not choose the right project to debug? Project Explorer. Oh, okay. Hang on. I think. All right. Yeah, I'm a bit foolish right now. Hang on. Let's do this. Yeah, I chose the wrong executable. That's why. All right. Yeah. Okay. Yeah, that's my mistake. All right. So now build. Failed to read memory. Not a problem though. Okay. Now, let's start by hitting the plus button or the start button. And now, yeah, now we're working. Uh-oh. Oh, interesting. Okay, so this one is much easier. I mean, it still requires some pressure on the buttons to activate, but not nearly as much as the 2. What's interesting though is that on the 3 here, is that it also turns on that LED. Definitely interesting. And then the 4 works as intended. Then on the back, as I would imagine, hang on, let me just grab some metal here. I would imagine then that as I put metal nearby, it is going to light up. This one doesn't seem though as sensitive as the 2 button. Let me just try a different piece of metal here. Let me try my hard drive. Alright. Alright, so as expected, this one also works just fine. So front it's more touch control, and on the back you have more inductive sensors, so these here are going to actually detect the metal. So now that I have this one done, I'm going to stop the debug. I'm going to unplug the device. And then change out the 4-pin or 4-button for the hover touch expansion board here. So it should probably be the same thing. It's definitely weird seeing it layered like this. You got, I mean, I see inside here. It's kind of hard to see on the camera. Let me see if I can kind of focus it. You can just barely see that it looks like there's inductive touchpads in there with their own LEDs. So let's see. I'm also going to take this apart because I see it's just held together by some screws. So after I'm done testing it, I'm going to take it apart and actually see what's going on with it. So let me connect it in. Alright, definitely a bit bulky. And now let's see what happens when I plug it in. Oh, hello. Kind of flashed a bit there. Alright, so as I kind of thought, nothing is working right now, as that seems quite expected. So now I'm going to do, project, no, I need to do a new application. This board, yes. Sensing, and now I believe that it would be this one here. And this is going to take some time to do, so once again I will be back as soon as this thing's actually done. Alright, now that it's all done, put the board back in. Kinda cool that the lights all flash across. Now, so the README here for this one doesn't actually seem like it has like any image of you pushing on the board or whatnot. And as I said earlier, that once I've just ensured that all these sensors work, I will be doing all these different things that they have just to test out. So here is the sensor, the hover sensor board here. And I will, like I said, I'll also take it apart, but not quite yet. I want to just get all of the sensors working and whatnot. Alright, and so let me ensure that this project is indeed selected. And now we need to debug it. Ooh, did I actually... Oh no, I don't think I hit the right one again. Oh no! No! Ah, no. Okay. Yep, no. Okay, let's stop. And then we need to do run configurations. And the cap sense. Hover, alright. That's right, that's good. That's all good. Hover touch. Alright, everything looks good here. Now I need this one here. Come on. Now, where is... Alright. Let's try it this way. Nope, okay, doesn't like that one. Alright, so where is project build? I'm sure the build button is around here somewhere. No. Not quite sure where the build is. Alright, but now it looks as though it is done, so let's debug hover. Program, okay. Now let's run the code. Let's see here. Woohoo. Definitely working. But you have to actually touch the button to turn on the LEDs. You cannot hover around even a millimeter off. You have to be physically touching this connector here. Anything on the back, bottom here? Nope. So I guess that this is the minimum area that it will detect, hence why it's set up like this. And you can see the LEDs are on the innermost PCB board. So, interesting kind of thing. Let me just grab a ruler here. Now let's see the minimum distance. Minimum distance is about half. Oh, whoops. Minimum distance is. Let me focus. So minimum distance here is about half an inch. Or, for those of you in the metric time, we are at just about
1.5 centimeters. Right? This is centimeters, yeah. So just under 1.5 centimeters is the distance that this thing will actually read from. So, nice little hover project there. Let me stop it again, because now we got a more, well, I don't want to say more interesting, but definitely unique thing. So, disconnect and plug, because now we've got to move this, and now comes the interesting thing here, where we have liquid sensing unit here. So this here has a strip in the back, and I'm going to put it then inside of this bottle. So let me and the bottle is actually like a brand new bottle. Alright. Now, not exactly. Guess I have to kind of bend this in a bit. Or does this go on the outside or the inside? Because it really doesn't want to go into the bottle. Ah, there we go. Alright, it is now not very well, but it is inside the bottle, I guess. Something tells me that I'm not really doing this right. So before let's damage this thing beyond repair. Let's remove. Alright, good. And some of the stickiness is coming off. So let's actually see if there's an ideal case to use this, because obviously it doesn't really fit in here, and then just connecting it to the outside, I don't really think that's right. That doesn't seem correct to me. So, when in doubt, Google. Alright, now. So, Google. Okay, I need Infineon liquid level sensing. Does it really go on the outside of the bottle? Huh. Interesting. Interesting. So it detects through the bottle using capacitance. So it creates a field. I'm guessing it creates an electric field through the container to determine the amount of liquid. Huh. How fascinating. Let's go back. Because I mean, even if you look at this image right here, you can see that it is indeed on the outside of the bottle. Interesting, okay.
Well, and if it does indeed go on the outside of the bottle, then I will take off this adhesive here. And I guess that I'm supposed to do it this way. Let me put it here. Now it goes all the way. Ooh, and it is definitely stuck. It's not exactly the most accurate. Let's see, can I? Oy, oy, oy. I'm afraid I'm gonna break something. Kind of make it straighter if I can. Alright, so it's not perfect, but it definitely is okay, I guess. So, let me connect these two together. Oi. Alright, well. Definitely some interesting stuff going on here. Alright, now I have successfully filled up the container with water, and I have also installed the liquid level sensing code. Again, everything here is exactly as it is in everything else. Let's see here. Is there something to actually tell me then the level? It seems as though this might just be a complete GUI situation. Is there no UART out to a console? I also have a glass, because I'm going to take out some of the water, and I also have a turkey baster, or if you've watched Ed, Ed and Eddie, it's a Canadian squirt gun.
Actually, they look like turkey basters.
Yeah, right, Double D. A turkey baster. What we have here is a squirt gun.
Please, a squirt gun?
What? Yeah, a Canadian squirt gun. Canadians are weird. Watch and learn, boys. Just Bill.
Even if they were Canadian, heaven forbid, I don't think they're...
And squirt! Canadian style.
I'm not seeing anything immediately saying that it is that, but that it's a UART, I should say. You know, so build. So I can have this thing all set. And let me see here. Let me bring up my device management, and let's see here if I can putty into COM8. All right. Putty 8. All right. So So it seems as though this is all good to go now. So let me do run configurations. Just make sure liquid level sense. Everything seems as though it's all set up. Alright, let's run it. Let's see, does anything actually print out then into PuTTY? No, nothing is printing out into PuTTY. And it seems as though the sensor isn't actually doing anything right now. So I guess this is truly a GUI only one. Huh, interesting. Okay, so let's go to the README and start going over things. Project's already created and everything. Alright, open CapSense Tuner from the IDE Quick Panel. CapSense Tuner. IDE Quick Panel. Guessing this here is the Quick Panel. No. So is CapSense here? No. Well, let's see if this here will tell me CapSense. Tuner. CapSense Tuner. I don't see it here, so let's see here. CapSense Tuner. Okay, so it is a separate app. Alright, let's do that and put that there. Can I maximize? Okay. Ensure the status LED is on and not blinking. I believe that it is correct. Oh, hang on, let me just zoom out a bit. Alright, so LED is on and not blinking. In the tuner application, tools, tuner communication setup. Click on the tuner, so it's over UART, I suppose. Okay. No. Okay. Setup. Interesting. I don't see the I2C coming up. Tuner setup icon. Okay. Let's do that's settings. No. No. Alright. Maximize. Communication. Let's do options. Display SNR. No. No. I2C. Yes. Okay. Alright. Tools. Setup. I don't have anything that actually says I2C on it.
It is plugged in, obviously, to the computer. Alright, let's see here. If I unplug it first. Unplug. Still running. Maybe that's the problem. Okay. Yeah, okay, so once again, stupid me, I forget that it's running and can communicate with anything else. So now, let's try this again. No, okay. Let's close. Maximize. Now let's try unplugging it. Okay. And now plug it in. Alright. Minimize. No, whoops. Bring it back up. We need cap sense tuner. Tools. Setup. Okay, here we go. I²C. Okay. Move that over. Put this back here. Did I miss something? Oh no, okay, everything's good. I just didn't look at the right hand side. Okay, so that's all there. Communication. Connect. Do I need to start it? Is it not powered or something? So I am hitting the start icon, but it is not doing anything. Communication. Connect. It is grayed out and not able to connect. It's weird that I'm having so many problems with this. So all this seems like it is grayed out. Yeah, all of that is grayed out. Back here, 2 bytes, 400 kilohertz. Yes, yes, okay. And connect. And it is just refusing to connect. Alright, I will look it up. Alright, so now that I have an idea of what I'm doing, I have a cup that I took all the water out of the container here. And now I'm going to plug in the microcontroller. I want to make sure that I have the set liquid level sense up and running, so we're going to just make sure that everything is in. Build. I'm going to go to the README here. Alright, so what you need to do to get this to actually work is you go to the quick panel here, which I had to go to Window, Show View, Other, and then type in, and then you just go down here to quick panel. And then I go to, where are ya? Here we go. CapSense Tuner. Alright. COM8 should automatically be, I squared C, so let's see here. Settings, why do I only have UART? Did I flash the wrong thing? Hang on, let's do... Liquid level management. Empty the tank before programming the device. Alright, so I did that. Let's recalculate here. Let's calibrate the sensor. And while that's doing that, let's see here. Why do I only have COM8? Let's see here. Maybe I accidentally hit the wrong thing. Oh, wait a minute. It doesn't see the kit. Huh. Well, that's weird. It doesn't see the kit here. Alright, we'll try this another way then. Let me cancel the calibration. Close. Give me 1 second, I'll be right back. Alright, I am back. I had to flip the USB around. Alright, now let's recalculate. Alright, so while this is calibrating the liquid sensor here, one thing that I'm going to note is that in order to actually get the quick panel to show everything, you can't just click on the main file you want to work with. You have to make sure that in the Project Explorer you have the project selected. You can't just do it by hitting the main.c file to do it. You have to ensure that you are on the Project Explorer, then you can go to the quick panel, and then you can go to the tuner here. So once I am finished with the calibration here and I demonstrate for you everything that's in this README, I'm gonna go back, like I said, over the other peripherals and just make sure that those work as intended in the tuner. So, alright. So, go here, I squared C, everything's okay. Let's connect to the device. Alright, I should be connected now. Yep, connected here, voltage 5.1567 volts. Alright. This is probably going to be the biggest sensor with everything that you can do with it, just because it's not just touching it, it has a bunch of levels that it reads and capacitance, so it's definitely different. Alright, so now everything is done. Let's go to instructions, connect, start tuner communication. Alright. Widget view. Foam, I don't actually have any foam in my house right now. Oh dear, I don't actually have any foam to test out this foam. But let's just deal with the liquid. So go to graph view then. Graph view. Ooh, hello. I definitely have a lot of values here. Number of samples 500, sensor data. Alright. I can close down this, I can open that. So I don't have any foam in there right now. As I said, I don't actually have any foam in my house. Switch to SNR measurement tab and verify that it is above 20:1. Liquid level 0 sense 0 and acquire noise. So SNR measurement, acquire noise. No sensor selected. Select the sensor from this. Oh, okay. Acquire noise. No sensor selected still. Did I skip a step? Hang on. Let's make it full screen, because why didn't I do that before? SNR measurement tab. Oh, okay. I didn't click the right thing. So it's this one. And acquired. Oh, hello. Okay, there we go. Whoo, baby. Now we're talking. Okay, so I just hit the wrong thing. That's my mistake. Alright, then. Fill the tank to the maximum level. Alright. Hang on. Let's turn on a little light here so I can reposition the camera a bit. Zoom in. Alright, so let's fill this thing up. So I'm going to take my turkey baster, fill up with water. Alright, this is going to take, actually maybe not as long as I thought it was going to take. Let's see, is anything actually happening on the graph?
Noise measurement is complete. Okay, so I don't actually see anything. Ah, green light came on. I'm guessing then that if I go to maybe something like widget view, aha! So I can see that the liquid level is going up. If I look at graph view, alright, then I can definitely see that everything is indeed changing. So, let me go to widget view one more time. And let me lower the camera here, so you can just get a better picture. Sorry for all the camera nonsense here, but I don't have a fancy boy camera. So, just take as much water as I can in. Oh, look at that. Oh, that's really neat. And if I go to the graph view, it's taking all this water. And you can get a good idea of everything that's happening. Let's finish adding the rest of this water in. Made a little bit of a mess, but it's just a table. Close it up. Oh, that is beautiful. Widget view. Alright, so it doesn't detect all the water right now. It might just be because of how I have the sensor positioned. I'm absolutely the worst when I have to stick something on. I will be the first to admit that. But I go here, and now acquire signal. Alright. And you can kind of see at the top the signal noise, the signal and the noise. Alright. Tuning procedure. What is this? Oh, it looks as though this is for something else, I guess. Oh, there's a lot of things here to do. Wow. I didn't actually think there was all these different things to do. Wow. Right now, if I do not actually plug my camera in, then it is going to die. So, I'm going to charge my battery, and then I will be back to finish off this large thing. Wow, there is... I mean, I know I can see the cursor on, or the position on the right-hand screen, but just look at this. Wow. There's a lot of things to do still. Just to configure this thing, I mean, it seems pretty good right now, but wow, that's amazing. Alright, so I'm going to plug my camera in, and then, because even though it said full battery before, I'm now getting a battery warning. So, I will be back soon enough for you. For the next stage of setting the initial hardware parameters, go to the device configurator. Another thing that I had to wait for to actually figure out how to actually do it. Then we go here, and let's see here, what do you want me to do? Cap sense. Okay, so I need full screen again. Right? zoom out. No, I cannot really zoom out. Okay. So I need cap sense. I have easy I squared C. Alright, that looks like it is. Save the changes and close the window. Parameters disabled. Can I enable them in some way? Oh, maybe I need to click it. Okay, there we go. Alright, so I need to click a bunch of things to actually show things. That makes sense. Alright, file saved. So I can close. Alright, so now I need to go back into the configurator tool. Basic tab. Hang on, let me maximize it. Alright, and now maximize this. Alright, everything looks good, and it's 9 segments here, and if you can see this, kind of, I suppose you could say 9 segments on here, and zoom better. In the back here, if you can kind of, if you count the actual amount of capacitors on the middle part here, you actually have 9, labeled 0 through 8. That, alright. That's done. Go to the Advanced tab. Advanced. Let me just do this. Alright, everything looks good. CSD settings. Shield active 240. Alright. Widget details tab. Liquid level 0. So this. Everything looks to be the same, okay. The FR. Okay, so before everything seems like it was just the default, right? Let's just double check here. Yes, everything looks to be the same. Okay, so back to FR then. Foam correction coefficient 410. It's 256 times the level of foam rejection minus level known divided by level of liquid level minus level foam rejection. I'm sure that all makes perfect sense. 120, but I'm just trying to make sure everything works. I'm not getting into the details of everything so precisely. Right, liquid presence level. I don't see that here. but it's okay. Go to the Scan Configuration tab. Select the pins and scan slots. Figure the pins for electrodes using the drop-down menu. Electrodes for the liquid level foam rejection are the same as that for the So these are slightly different, but I believe that because this is for the 4000T, not the 4100T, if I go all the way back up here, yeah, this is for the 4000T or the 4100T, so right now the settings I believe are for the 4000T on the readme here, so I'm going to leave them as the 4100 default that I see here. So scan configuration, I'm going to leave these alone now. And I mean, we can always see, of course, if something happens and they just aren't right. But I'm going to go ahead and say for right now they are right. Can I even change these? I can change these. Because it doesn't say this is for the 4000 or 4100, but I'm going to assume this is for the 4000. Alright, so it looks as though now this is all done, so I will save, close, maximize. Okay. Oh yeah, 5th generation. I believe, if memory serves correctly, the 4100T is 6th generation. So here, these are just clock derivations. Program the board and launch CapSense Tuner. Alright, so the board is already programmed, so let me launch the tuner then. Okay. Now, go back here in full screen. Alright, so waveforms of the sensor. So somewhere there's a waveform of the sensor. So let me just start by connecting and read the data. Let's go to widget view. No, graph view maybe. So maybe sensor no. Status now. SNR measurement, no. Liquid level measurement. Let's see here. Show logged level. Oh wow, okay. Liquid level. I don't see exactly where this is. Where is this? Waveform of the sensor described earlier. Let me click on this. Oh, sensor clock divider. Can I see this? Can I actually see it though? Oh, this is just a value. Oh, these are just the value ranges. Okay. This is not the actual thing. So then where do I actually see such graph? Read mode, synchronize, yeah, that's fine. I don't see where these signals are supposed to be. Alright, we'll just skip that. Whatever, it's okay, it doesn't matter right now. Sensor must provide a large signal. So this is the filtering, and if I remember correctly, if I go to the configurator, not here I know, but I'm just looking. Right now, I do not see a tools. Nope, I don't see it. Okay, I'm gonna close this. Don't save. So because I'm not sure exactly in the operation section. Here's operation. Step 9. Did I miss it? There's 8. Huh. I don't see step 9. Go back down to where I was. It was already 128, but this, whoops, wrong. Here, CapSense tuner, and then I also need the configurator, so let me just open both up. Minimize, tuner, oh, yeah. Here, yeah, 128 as the sense clock divider. Okay, so that is exactly what I thought. Here, go to scan, no, go to advanced, and it's 128. So now it seems as though it should be tuned. Sign and implementation. Set up the VDDA supply voltage in debug mode in the configurator. Should already be set to 3300, but let's make sure. System, power. Is there another one? System, power, VDDA. Oh, no, I have 5,000, but it here wants 3,300. Voltage is not greater than 4 volts. I am following the instructions on the thingy, on the README here program, so don't be mad at me. debug mode. That is in the system debug. Yep, that's right. Peripherals, settings. Yes, everything's right. Alright, and it looks like that's that. So then, let me just save everything. Go back to the main.c file. Let me just build it again. Now, I'm going to program the board. Go to CapSense Tuner. Do I have CapSense Tuner open? I do. Not. CapSense Tuner. Okay, let's go to the widget view. Connect. Failed for some reason. Okay. Why did you fail? Oh, why is it set to E1? Huh. Because it's not actually on the PSoC here. Let me stop that. And I will reset the board. Now let's open up Tuner. Loaded. Start and connected. Let's read. Graph view. Huh? Alright, so I'm getting data. Let's go back to the widget view. Interesting. I don't see anything happening here. Let me take out some water. Up. Then, so somehow, some way, it broke. Let me stop and let's make sure, disconnect. It is connected to, okay, I2C, yes, that's right. Connect, play. And let's do this. Let's acquire the noise. Alright, then acquire signal. Okay, let's go back to widget view and still nothing. Huh. Interesting. Looks like it failed, as I can understand, because it doesn't look like it's doing it correctly. Nothing. Alright, well, that's something, I suppose. Okay, well, I'm going to say that as of right now, I have finished the Liquid Sense Tuner, and I'm going to go back then to the 2-button touchpad. So I will do that. Alright, so here's the 2 buttons. And like I said with the liquid sensor, everything here is made for the 4000T, so I'm sure that all the signals are automatically done for the 4100, and the README just doesn't have the connection. So I'm going to plug the board in right now so we can see what else is done here.
this, okay, so I've already done this where I touch a point. Let me just, of course, this is the 2 buttons, so I'm going to, where is it? Attach. I don't want to attach, I want to actually debug. Here we go. Alright, so it has to build everything, okay? But then, what happens after this part? That, okay. Well, I'm gonna have to go back to the tuner then, okay? Alright, so that's all good, it looks like. Then if I do this, I gotta start. Alright, yep, exactly what I thought. Screwdriver, let's just test out the metal. Yep, metallic works on the back. Alright, so, read me. And go to the, I believe this is the quick panel here. Yes, okay. I need the tuner, so let me refresh the quick panel. Tuner. There you go. Alright. I want to close this down. I can just see the difference in the variations of the readmes. I don't see it starting. Tuner. Alright, there we go. Alright, so establish a connection. Wish I could zoom out. I cannot zoom out. So here, settings, let me hit stop, and just reset the board, close that. No, okay, I have to close down the tuner, and then just reset the board again. Tuner off. There we go. Okay, okay. And then connect. And then play button. Then select everything here. Go to make sure it's synchronized. Rigid view. So if I push it now, alright. And as normal, I have to really push it hard in order to get it. I'm guessing, okay. Same thing over here. Both of them together. Man, those are really tough buttons. Alright. Graph view. Oh. Alright, I can see things changing here when I push on the buttons. Very good, very good. Push button 0. And I'll push button 0. Maybe I need to just disable these things here.
Hang on. Legend. Alright. Alright, so blue, definitely. Okay, well, I mean, everything looks like it's working, right? SNR measurements. Close that. So I need to select the button sensor, acquire the noise from it. Cannot touch the sensor, okay. And while it's doing that, and acquire signal. And then when I'm acquiring the signal, my finger has to be on the button at all times, okay? And then I also have to do it for the SNR. Touch this and acquire. Cool. All right. So that passed. Wonderful. So now I disable this, enable that, click on that, then I just repeat the same steps. So acquire the noise. While it's doing it, no, nothing at all it seems, okay. And then, I'm curious, is this tuning procedure supposed to be done before or after I actually test everything out? I mean, the way it's done, it seems like it should be after, but don't you want to tune things before you actually use them? Am I crazy for thinking that or something? Oh, okay, so the noise is being done. It's exceedingly slow. Because it's only giving 22 packets a second? Wow, okay. So I know that I'm going to need the device configurator. So I'm just going to open it up right now, not change anything. Don't worry about it. Warnings, you know, there's always warnings. Alright. So we'll get to that. Where is this? Okay. This is noise. So now I'm going to get the metal and acquire data. Maybe. Maybe. Oh, is the bit itself not magnetic or something? Oh, it is. Maybe I'm just getting it at a bad angle. This is weird. Why is it so slow for this? It's much faster on the liquid silencing and on the button. So just because this is an inductor? Ah. Acquiring signal. So then why are you so slow? Why so slow? Huh. I don't know why this is taking so long. Because it's not moving. It's just not doing anything, so I'm just going to abort it and we're going to try again. Acquire signal. And it's not doing anything. Huh. Well, alrighty then. Then we're just going to ignore it and move on. Don't save. Ah. Oops. My bad. Alright. So, CapSense, MSCLP, yep. Here. Yeah, everything is right. Now I need to go to the configurator basic tab. So this is the device configurator and then the actual CapSense configurator. So open this up. Basic. Move it over here. Basic. Everything looks to be the same. Alright. Let me full screen this actually. General tab under the advanced. So 46 megahertz, one divider, 62,500, 160. Yep, everything is looking the same here. Looks good, looks good. Go to the ISX settings. Make the following changes. 35%, okay. Go to advanced widget details. I don't know why this was blue, but whatever. Or not standard text. Low power 0 on the left plane. Is there no image? Okay. Sense clock divider. Sense clock. Oh, I guess this is it. Okay. Clock source direct. Subconvergence. Oh wow, 766. So you will set that to 60. Finger threshold. 100. So we're going to set it to the maximum, which I believe that's 12 bits. Let's just make sure. 2 up to the 12. I am most certainly wrong. It has been a hot minute since I've actually tried to do this. 24. Okay, I am really just embarrassing myself. I should really know this by now. 16. Okay, so 16 bits. Oh, duh, it's a 16-bit ADC. Okay, noise threshold. Set it to 10. So this negative noise to 10. Set the low to 10. On debounce to 3. Go then to
select the other regions and repeat the same configuration for those. Oh, I see, okay. I don't know why this is different than the other. So this, set this to 60, set this to 65535, 10, 10, 10, 10, 3, 60, 65535, 10, 10, 10. All right, and then one more here. 60. I don't know why they didn't just do this to begin with and, you know, have these defaults, but who am I? Noise threshold 10. 10. Low baseline of 10. On the bounce 3. Okay, so that's all good. Go to the scan configuration. Figure pins for the electrodes. Auto assign options. Let me just go back to full screen. Full screen. I mean, I'm just gonna go by the. Oh, it looks like I broke something. Can I control Z? Yes, I can control Z. Okay. So I'm going to save right now. It seems like it's good. The LX, so the inductor clock divider. Alright, so I'm guessing this is the divider then from the system clock. So 46 megahertz system clock, and you do the divider for the inductor by 36 by following this formula. Filtration system and sense. Again, I have no idea where they get this graph from. Maybe it's from an oscilloscope? I'm guessing that's from an oscilloscope, but I don't know because it doesn't actually say. It doesn't look like it. I'm just going to leave everything as default. I already checked all these things and this was all the same. I will just go back though and make sure. General 146, yep, okay, so everything here is the same. Alright, so I can just save, close, shrink. And build. Alright, now I'm going to run configurations. I want 2 and I want to attach it. Run. I'm going to open up device configurator. Wait, no, wrong. I need CapSense Tuner, that's what I need. Alright, let's connect, no? Okay, so it keeps on resetting that. Alright, so it seems like I cannot run, so I always have to stop it on the IDE before I can actually do anything else in the tuner. I guess that kind of makes sense. So, enable, disable this, graph view, right? Yep. Alright, and now I should be able to push the button. Oh, whoops, I need to actually connect first. No, okay. I guess I need to restart. See, reset. Open up the tuner. Let me make sure. Okay, now that works. Okay, connect. Start acquiring. Push. Alright, so it looks as though it does see the push even if the LED doesn't come on. I just need to really push hard for the maximum amount, it seems. So, maximize this again. Now I'm supposed to see the position graph as well. Number of samples, wait. The number of samples they have is 1,000. 1,000 samples, okay. So why is the position graph then not doing anything? Maybe I need to select the button. These are all the settings. But the position is not doing anything. So the sensor's reading. Wait, am I? Oh, it's the status. Okay, my mistake. I don't read. Aha! I don't read, and that's my problem. I only focus on what I'm seeing, not what I should actually be doing. So now I sense and I push. Okay, so status push. So it can sense, but that doesn't mean that it's actually on. So only when I push to get the LED on, then does it actually do something. Okay. And this is what it was set to before, so 80%. Okay, so these are percents of the signal. So it says, so the threshold parameters, but my parameters are in the 13,000 plus range, not the 400 range, because I'm not on the right one again. Okay. Whew. It's been a long day, ladies and gentlemen. It has been a very long day. So, I see right now. Let me just set. Alright. Let's say here, finger threshold 120, noise threshold 60. Negative threshold 60, hysteresis 20. And now back up. And it's still kind of, I mean, it looks the same, but it's definitely, I guess, looks kind of cleaner with those settings, I suppose. But it looks like it's working as intended. Alright, for the low power low power sensor. So for this, for the low power 0 underscore sense 0, the low power sensor threshold to that application to enter low power mode. Where do I do that at? Here? I don't see that there. Low power. I don't see that immediately. All I see is low power 0 that, so okay, but then where is, well, okay, so let's just say that, and then I'll set this to the maximum it says. This is the import. Oh, maybe in the configurator it said that? Well, I already did that. Right. But for the low power button. Let me enable that. Don't see the line moving up at all. Oh, wait. What am I supposed to be looking at? Sense diff count and status. Am I missing something? Because I really feel like I'm missing something here. I mean, the instructions say things, but it doesn't really seem exceedingly clear. So let's just keep moving. Because I'm getting really confused with why things are being said, but there's no real demonstration in it. Right, this kind of looks like, okay, this does look like an oscilloscope. Oh yeah, this is an oscilloscope screen reading. But I do not have an oscilloscope to do this stuff. Right, so this is doing the same thing we did before, and it seems as though everything for this thing works as intended, so I'm just going to move on. Alright, I have the force sensor then, and then the hover sensor thing still to do. So, I'm going to complete those right now. Alright, as promised, now is the time for the 4 buttons. And the monitoring on the tuner. You would imagine that with a name like tuner, that everything would be, well, tuned in the tuner. But no, there's other configurators for it. So, okay. So I'm going to first do run configurations.
I need metal attach, run. Quick panel. Let me stop it because it can only talk to one thing at a time. Tuner. Ah, look at that. Look at all those options now. Alright, full screen. And then we are going to go. Make sure. Check some mismatch. Check some mismatch. Something not right. 2 bytes, 400 kilohertz. Okay. Check some mismatched. Okay. Let me close it down. Let me just go back here. Project. Let's build the project again. Alright. All done. And let's run it. Alright. I'm guessing it's working now. Yeah. Let's reset the board. Something definitely seems odd. 1 is lighting up 2. 2 is not lighting up anything. 3 is not lighting up anything. 4 is lighting up 1. Reset it again. Let me stop it. Did I not? No, it's supposed to be doing the 4 pins, the 4 buttons. Alright, we'll do it another way then. Let's run it, but this time we will run it as debug, run. Programming, okay. There's no zoom. Alright, we are back in business. So now let me open up a tuner. Now let me connect to it. Okay. Now we are all good. We are connected and we are recording. Widget view. Let me just turn all options on. Go back to the README. I don't know why it's showing only 2, why it's using the 2 button one for this, but whatever. I will do that. Oh wait, I think that's for the inductor. Maybe. Maybe not. I'm not quite sure what this one is for. Because I mean, it looks like it should be for like a battery sense, maybe? Here's my phone. Let's see. It's not detecting anything. Let me get an actual battery. I luckily have. And nothing. Huh. I know those batteries have at least some juice in them. Okay, let's just make sure that the button works. So this is labeled 0, 1, 2, 3, but the buttons are labeled 1, 2, 3, 4. So it's actually 0, 1, 2, 3. That's why this is working like that. Then graph view 1000. And as you can see, I'm rapidly pushing, but it's not really doing it. I need to really push harder for it to happen. Alright. I have this here, so I have the legend active, but it's not really doing anything. Right, I don't really have any of those options. Touch sensitivity, hang on. Button 2, touch sensitivity in microhenries, 0.1. Yep, that's exactly it. So 100 nanohenries. Okay, well, I mean, it is sensing it, so it's not like that's a problem by any means. So, Alright, on to the next thing. This works, I suppose. Going down then to this here. So I need button 1, I believe. Or no, button 2 is fine. And I need to acquire the noise. SNR, select the button and acquire noise. That's a very interesting noise level that I'm seeing there. It's very bound. I suppose that's a good thing though, right? I mean, it's not that noisy. Alright, so now touch the sensor and acquire the signal. Alright, so looks like that works just fine. It's a smooth signal, I see. Okay. Noise. Signal. That doesn't seem too bad to me. That's very low noise and a rather healthy signal, I suppose. Keypad 4. Meanwhile, I only see 2 options here, so they need to really reread and go back over these things to make sure they're correct. Alright, so now, again with this import. What am I importing here, though? Alright, let me go to the thresholds here. Touch sensitivity. Well, it says for the low power 0, so it's for the inductor, right? Because it's the RXLX. So I'll go here, finger threshold, 65536, 6. Wait, what? Am I being stupid about something? 65535. Oh wait, am I just 3, 5? Oh, okay. I was hitting. Okay, yeah, that's my fault. I was hitting 6 instead of 5. Okay. Apply the changes to device. So I just hit this then? But I'm importing a configuration file. That doesn't seem right. And I don't see any other import or download to device style button. I did nothing. Import. What do you mean? I don't understand what this is saying here. Well, now it's time for the inductor anyway, so turn that off, turn this on, and now I will do the same thing here, acquire the noise. Well, it does that, then I will acquire the signal for 3 newtons of force. Well, I don't really know how many newtons I'm pushing on. Alright, let's see, so this is still going. And for this, then, this is the device configurator that I'll need to play with. Alright, let me unmaximize this then, and I'll open up the device configurator. Yeah, blah, blah, blah. Worry about updating it later. Go to peripherals. And maximize this again. And we are still acquiring the noise. Oh, there's the log in the bottom left-hand corner. Do 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 do. Is it me or is the... Oh, nope, there it goes, okay. I spoke too soon. It just seems very slow at acquiring the noise. It's because it's on a magnetic... Well, it's not really a magnetic table. It's just a metal table with whatever this material is called on top. Come on, you can do it. Hey, okay. So now we need some sort of metal. So I will do this and acquire the signal. Right now I'm actually attaching, or just holding the board to my computer, and as you can see, the light's on, So it should be doing something, but it isn't. Let me see. Does it want me to push on it? No. Doesn't want me to push on it to activate it, I don't think. There is some more metal. Metal. I have so much metal on my desk, and yet I'm so indecisive. So I'm looking for this. Idea. Screwdriver. Let's see. Yeah, it is not acquiring data still. So it's just like the two. This one doesn't work very well at all. Okay, moving on then. Abort. Don't save, please. Just get out of that. Thank you. Alright, so now you want me to set this up like so. Okay. So let me do that. Do this. So you want me to enable the PWM. Okay. Cap sense that. Let's shrink over a bit. Thank you. Okay. This is the four keypad demo, so are you gonna tell me what I need to do for the PWM? No, you're not, because now we're going back to the CapSense configurator tool. Okay, so I'll just assign the clock then, I suppose. Save. And close. Alright, now I must CapSense configurator. Config. Okay. In the basic tab, configure the button widgets. So basic, set everything to full, it looks like. So buttons to full. Which they already are, okay. And I need to keep the touch sensitivity of its default of 0.16 microhenries. So right now it's 0.1 microhenries, but whatever. Okay, I'll just leave it as default. So that's that. And so advanced tab. 46 megahertz, yeah. Clock divider, whoops. And that works, I guess. Clock divider 1. Set the number of initial sub-conversations. Default value, default values. Wake on touch interval, okay. 62.5 milliseconds. Okay, seems like it's all good. Yep, everything's all good there. Alright, advanced widget details. Low power 0. Touch sensitivity. Retain the default. Clock source direct. Finger threshold of 65535. Noise threshold 10. Low baseline reset 10. On debouncer 3. And do the same thing then for these other buttons. So leave everything the same. Finger threshold is 65535. Noise threshold of 10. Negative noise threshold of 10. Low baseline 10. Did I change that for low power 0? No, I did not. Alright, so 10. Here. 35. Oops, come on, 10. 10. Come on. Come on, click. Thank you. 10. Come on. 10. Thank you. Alright. So save because I don't want to have to keep doing this. 65535. I cannot just tab my way into it. 10. 10. Okay, so everything is now like this. Go to the scan configuration. Configure pins for the electrodes drop-down menu. Electrodes drop-down menu. Electrodes. Oh, electrodes right here. Okay. Drop-down menu. This is not a drop-down menu. I only have RX0. Auto assign slots is right up here. Unless I need to go down to the buttons? Nope, those still are not it. Why are you like that? Never. Okay. Just, I don't know why this button is different. Whatever. Alright, next. SNR. We'll go back to advanced. The general settings. Need to enable all these things. Those are all done, okay. Tune threshold parameters. So now I need to go back to the capsense tuner, it looks like, yes. Save. Close. Capsense tuner. Now I need to go here. So select it like that. Graph view. Sensor data. Let me just minimize these. Alright, sensor data. Number of samples 1,000. Okay, so I suppose then I just push and nothing happens. Okay, let's then do this. Nothing happens. Does it want me to actually push on the bottom? What is happening? Trying to only push on one and nothing works. Okay, so I once again seem to have broken something. How lovely. Yeah, guys, I'm just gonna say forget the rest of this because it doesn't work. It once again just is not working. I'm pretty sure I did everything it requested of me, but what do I know? So I'm going to now flip over to the hover sensor. I will be right back. Alright, here is the hover sensor ready to go. So I shall plug in. Always interesting seeing the lights do that, so let me now expand code. Alright, monitor the data with the CapSense tuner. So let me hover touch and let me come up here. Hover touch, run configurations. Hover touch debug because the touch never really seems to work. I don't know why that's not doing anything. Let me unmaximize hover touch. Run configurations. Hover touch. It's weird. Why can I not run you? Oh, do I need to debug it first? Hover touch. Here you go. Let me try building it first. Maybe it just doesn't like that it doesn't build or something? Should still be built though, from last time. Alright. There we go. Now let's try running. Hover touch. Oh, okay. I just need to build it. That's okay. Fine. Whatever. Alright, now run. And now, yep, everything works as intended. Alright, so now you want me to go to the tuner. Yeah, all this stuff, normal. And then turn it on, so all buttons come on. Ugh. Back to here, stop it. Now let's see here, now I gotta restart it. CapSense tuner now. Hopefully, please. There we go. Okay. Spread C, and now widget view.
Oh, whoops. Ha! I forgot to start it. Start. Okay, now. Ooh. Nice. Does it only do one at a time? Only one LED can come on at a time, but it will detect all of the buttons. That's interesting. Okay then. Let's go to the graph view then. Graph view, turn off these things. It's a little mushed together, but kind of expect that. Sensor data, diff, and status. Status. Alright, so everything seems to be working just fine the way it is. Alright, SNR time. So SNR measurement, click that, acquire the noise. Oh, there we go, look at that. Look at that noise. Alright, then acquire the signal. Can't really get any closer, of course, since this plastic cover is in the way. I will remove this soon enough. Alright. Set the initial hardware parameters. Launch the device configurator. Full screen. Move over. PWM that 1.0. This doesn't have a name, so let's just do that. This is the same. Alright, so now save, but I need to assign a clock here, so I'll assign the clock. Save, close, full screen, configurator. Alright, the configurator. Everything looks the same here. Add 4 buttons. Well, all the buttons are... I don't really see what it means. Add 4 button widgets. They're already here. Okay then. General tab. Advanced. CSD settings here. Shield. Active 185. Okay. With the widget details. Select button X from the left pane and select the following. Everything here
Everything here looks the same. Alright, this here is an oscilloscope, and I don't have a good enough oscilloscope really to test this out or even know where to probe anything, so everything is auto. CDAC and fine CDAC, so that's there. I don't think I need to change anything here. Alright, then go back to advanced general. Enable the median filter. Deactivate it, I guess. Yep, okay. Step 8. There is no step 8. Is there? No, there is no step 8. So I don't know what in the world these people are talking about. Everything looks the same here. Save. Close. Graph view. Well, that does not help at all. Graph view, select button 1. So it looks like all of the points do get triggered by just hitting 1. However, it's definitely not as high. Like there's just some noise, it seems like. Yeah, even here I see the noise. It's kind of interesting. Thresholds. Yep, these are all the same. Apply to device. This does not apply to the device. This imports things. And I do not see anything else. Well, here's the apply to device, but it doesn't do anything. Like this is just grayed out. I can't even do anything with it. Power, I mean, this is all just changing the thresholds of everything and stuff. Yeah, I'm curious. Let me go back to the configurator. Yeah, the configurator here doesn't have anything that says send to the thing, to the board. What about device configurator? I'm pretty sure this happens before you actually do anything. Yeah, there's nothing about sending to the device here that I see. This is for pre-programming. So it seems as though all of the demo stuff that they've given me is now done. So next thing I wanted to see is, because this is still programmed like this, I'm going to take off this sandwich thing and see what it's like underneath and just, play around a bit. So I will be right back to do that.
Alright, here is the thing. Where did I put that screwdriver? Here it is. Let's take this thing apart. It has 4 plastic screws. 1, 2, 3, and come on. Here you go. 4. Alright, so this here, just a piece of plastic with some labels on it. This is the board. I gotta flip my heads now. Okay, here is the flathead. Let's take this thing apart. And see just what is going on. So this just seems like some, maybe it's a backboard just to break any interference, maybe? Not quite sure, but here is the main board itself. Let me I can see that there are still some touches here. I see there's some missing resistors. Let's see if I can get close enough. That does not help, camera. There we go. So it looks like R12 and R10 are missing resistors. I'm sure there's a good reason for that. But I want to see now, will the board actually work still with the things off? I mean, I wouldn't see why it wouldn't, but, I'm curious, so let me be able to maybe plug it in. There we go. And too much stuff on my desk. Plug it in. You can see everything is still working as it should be. Let's go to the bottom. Oh. Interesting. Oh, this is kind of glitchy on the bottom here. I'm only touching the 3rd button here, but as you can see, it jumps over to the 1st. If I hit the 2nd, it stays. If I hit the first, it stays. Hang on, let me reset the board. Okay, so top, still the top. On the bottom, touch 1. So if I touch the bottom of 1 only, it can slide over to 4. Reset. If I go to 2, it can slide over to 4. I am touching 3. That slides over to 2. 4 also slides over to 2. Interesting. So maybe, that's weird. Because if let's just say this is back here. Reset the board. You know what? I never actually tested this thing with the backboard on, so let me do that right now. Just reassemble it. In case it wasn't obvious before, I am literally just going through this as best as I can, any way I can. Come on, I know you fit in this. Tighten this down, make sure this is all good. They're all good. This is the ground board. What I'm putting back together is called the ground board, so it's like a reference plane then, I guess. Now reset. Oh, okay, I get it now. Alright, so when I touch on the back now, nothing happens. Because this entire thing is poured with just regular metal. Or copper, I guess I should say, to be more specific. So in any electrical system, you have a ground plane for reference. So I'm guessing that the way this board here works is that it's producing the signal. Of course, because these are capacitive, they're emitting a field, that's why it can sense me. But it's using this as kind of a reflection, because whenever you have an EMF hit ground, it reflects back off of it. I'm really oversimplifying everything here just to keep things nice and short for the layman. So essentially, this board on the back here is acting to make sure that you can't actually touch anything on the bottom. So only on the top will everything work. That's pretty neat. Okay, so it seems as though that's how it works. Cool. Alright, so switching microcontrollers for right now. The main purpose of the 4100 that we've been using is so there's an easier way for analog signals to be processed and have a lot of analog sensing. So what else is there in this world that we typically use besides just buttons? Well, screens. This is a 3.5-inch resistive touchscreen, an Adafruit one. So right now I have my TM4129EXL development kit, and I have it hooked up to the screen for the analog channels. So in my code here that I've written for the TM4C, I have the system control initiation, and then I have a bunch of functions here based off of the GitHub page that I found for the screen. And this just defines the number of samples that it's going to take, the pins for the analog in, UART initialization, then test point. So it creates a few structures, creates a function for reading, and then a function for switching between when the analog reads and then when it's just switching ports. So I switch between the X and the Y. So X is for the X direction and Y is for the Y direction. Each one has a positive and negative. And so I am trying to just go over to this one function and switch things around and be able to read the analog values that come from the analog sensor that's built into this board, or to the LED, I should say. And what I'm also doing here is that I am actually reading the pressure that I am putting on the board. So the harder I push, the larger of a value of Z. So I have X, Y, and Z, or X, Y, and Z. I don't remember off the top of my head which is which, but I'm going to get something based off of the resolution of the analog sensor. So I'm going to debug this. And I'm going to run, and when I push on the screen, I'm going to get some readings based upon how hard I touch and where it sees the position. Now, as you can see, it's quite sensitive and definitely reads quite a lot, because I don't really have a break in here anywhere, so I have to just kind of touch really quickly. And of course, it's not the most accurate for some points, but it's good enough for what I need. So I get rough estimates of where I'm pushing on. And of course, if I drag around, I get all sorts of values. Push harder, and I can get harder, larger Z values. So it isn't the most accurate in the world, but for what I would do with it, it is. So what I'm going to do next is I'm going to translate the code that I have here on my Code Composer Studio and put it in the 4100. So I have found the addresses for this microcontroller that I'll be using. And so I'm going to open it up right now and we'll begin the coding process. Alright, so now with the IDE opened, I'll do File, New Project. I'll create a C++ project, C. And now let's do project name. I'll just name it LED touchscreen. Can just do an empty project, I suppose. Next. Debug release, yes. Next. Toolchain name. Sure, why not? Finish. Alright, LED touchscreen. Open up. Includes, it doesn't include a C, but that's fine. Let's new source file. I'll just name this main.c. All right. So, with this now, let's see here. I'm going to, what I never saw though is pick a board for it. So maybe I don't need to worry about that yet. Let's see here, debug, configurations. I probably need to build it first, but Not gonna worry about that quite yet, so just get rid of those comments, don't really want them. Include stdint.h. No, not that. Include stdbool void main. Okay then. And then I'll just have some while true here. Alright. So let me build the project. Three errors, okay. It's weird that some IDEs require you to make it an int and then return something. Project build again. Still three errors. What don't you like here? Included header is not used directly. Okay, fine. I will just create a variable u int 8tb. Now, does that fix any of the errors? No, hang on. Build project. No. What is your problem with this? Undefined reference. All right. Let me just build all and see if maybe that helps fix some things. So while this is building all of them, I'm going to bring up the datasheets. Right, the first thing we should do, I do have some of the information up. Let me just, of course, given the schematic that's on screen here, I want to make sure that I can actually turn on the screen. So I have to find some wires, some jumper wires here. Okay. So let me see here. I have ground should be pin 2, so I can put it probably right there. And then P4 VDD. Do not use that for powering the device, for then I should use 7, which is, I believe, right here. Alright, so let's see here. This to be the power. So ground in, power in. And that is not turning on the screen. Wait a minute. Am I plugging things in correctly, though? Oh, no, okay, I see. So on the back here, so the bottom here is where the real amount starts. Let me get this closer to the camera right here. So down here is where it starts, and then it goes up instead of. So it starts from the bottom and it goes up. Alright, so let me then change this. So this is ground. So ground I can plug into here. And then power needs to go into. Huh? Hang on. I will figure this out. 7, I believe. I believe that's 7. Yes, okay, I see VDDA right there. Let's plug ground back in and plug this in. And my screen is not coming on. It's supposed to be able to take 5 or 3.3 KPV bus. I guess not VDDA. I do not use for powering. Oh, okay. My mistake, my mistake. Alright, so I need to use KPV bus, which is the third one down on the other side. So I switch to this pin right here. And now, I see this here, this LED comes on. I'm guessing that tells me then that I have something plugged in wrong. So let's see here. KPV bus. So it's this pin right here I see. So according to the schematic, 2 and 8 should be ground, but I should also have a ground right here on this pin. Okay, I can see very, very minuscule pin 1 here and pin 2 here. Alright, so if this is 2 on this side, right here, then that means then that I should put, no, I should put then power right there. Connect ground. And now, screen should, come on, hallelujah. Okay, so, that works. Okay, so, I can turn on the screen with my microcontroller here for the PSoC. Next, I gotta go through the registers here, and I'm going to try and find a way to actually print up the results of what happens when I touch on the screen. So I'm going to find more information and I'll be right back. Okay, so right now I have the touch screen up with the connections into the analog connections. So now I can push on the screen and I can get coordinates on my COM here. So what I wanted to do was use the raw addresses and all that stuff like I showed before. However, unlike the TM4C datasheet where all of the addresses are shown with an example, sort of, where it tells you exactly how to initialize everything, I couldn't find that with this. So what I ended up doing was copying and pasting a bunch of code from GPIO pins instructions, the demo instructions. Essentially, I had to go through a whole bunch of other things like UART as well when I translated my code from my Code Composer Studio to here. So, it's not exactly what I wanted, but it works. For the most part, it works. So, I didn't want to go over all of my time spent trying to code this because it took quite a long time. I had to do a lot of deep dives and everything. So unfortunately I couldn't show all this code, but essentially just go through all of these other examples that are on the screen here, or everything that I have in the Project Explorer, pick and choose, cherry pick, go then to the device configurator, and then just, well, first I have to select the project, of course. Select the project, okay, so project selected right there. device configurator. And it should come up. Device configurator, okay, right here. Then I just selected an LED, made sure that everything was good for it, went to peripherals, set its associated PWM signal here, fixed all the things that I needed to, assigned it, went here then, made sure everything was right with the Infineon code itself, then make sure that all of the code that I translated over worked. So for this, unlike before where I used the raw registers, here I had to actually set the drive mode for each pin. So the XP, the XM, so X plus, X minus, Y plus, Y minus, I had to change them to either a pull-up or an analog high Z, which is just high impedance. Change all those things, wait 20 microseconds for the system to all flip over and make sure everything is stable and everything. Finish off here. And then I also have, which doesn't exactly work the way I would hope it does, but it's better than nothing, where I have an LED come on to determine the amount of pressure that I put. But because my class here, or my structure here, it doesn't really seem to work very well for this PWM output. I even had some trouble trying to know how to do the UART. So before, I would just print out the P1.x, P1.y, P1.z, but those did not have this strict UART function. I had my own UART function that I was using to actually program it in. So I had to play around and put everything into a buffer, that way I can print it out. So I will go to Project, Explore, select the project, back here, Project, let's build the project. Alright, now there are some warnings that are supposed to show up, but I have some problem apparently where it all depends upon what you select that you actually see the warnings versus if you don't see the warnings. So I need to select, I don't know, it's really strange to me about which way I can actually get the warnings and which way I can't, because there are technically two warnings that are supposed to show up but for some reason do not. Let me just build one more time. Let me see. Do they show up? No, they do not show up. Okay, well, let me go then up here. Let me do the, well, let me try attach. Let's see what happens if I try to attach it. Because I've had horrible luck with just attaching. I've had to go with debug. Let's go here, COM8. Alright, and there we go. So as you can see, I'm getting a bunch of values here to determine my X, my Y position, and also the pressure I have. Now I'm getting some negative values depending upon where it thinks I am, which makes sense if I had a ADC with range of 0 to 2048, but then shifted backwards to negative 1024 to 1024, or 1023 rather. So it determines, so it's all based off of how the bits are done. And if I'm going to be negative, if it's like even around 0, where it's 1024 on one side and 1023 on the other, or if the range is actually 0 to 2048. So overall though, it's pretty much correct, I would say. The pressure though for my Z is most certainly not quite as accurate as it should be. Also, as you see, my LED doesn't dim when I'm not touching the screen. In fact, it doesn't really seem to do anything at all. So, I've been playing around with this, trying to get it to work correctly, but unfortunately, it just doesn't want to be the most accurate thing ever. But it's a good demonstration of the capabilities of coding. I also have a light dimmer that I'm going to demonstrate, and that uses not these LEDs but this ALS here, the ambient light sensor, to dim the screen. Now, I haven't combined these because it's really two separate entities, but I'm going to go into that. So to program this kind of microprocessor, you could backtrace everything. You could just, click here. I see all these things, and then I click here, write string. I see, this FIFO size, I gotta click into here. Oh, I see all sorts of things here. Let's see what these are. So I can backtrace everything all the way to actually know the initialization and how everything's set up, which normally I would do, but I just didn't feel like it was needed for this particular thing because everything is already nice and neat, and I want to be able to not spend months debugging my thing, determining what's actually needed, what's just there for ensuring your inputs are correct and whatnot. So I went with this standard code because it's supported, and in case I had any issues, which I did, and I had a contact support, they would say, okay, we'll help you out. You don't need to worry about translating your code into our language instead of your register access. So I just went with this for simplicity in the end. So this kind of works, kind of. Might also be overflow. 1024, negative 1024 might just be overflow. I'm going to say that Y is probably the most accurate, and Z is just, I have no idea what Z is doing. So it's definitely more accurate on my TM4C microcontroller than on this one. But on my TM4C, I had more direct access. I was controlling all the registers and I knew how everything happened. Here, it's more about guess and check and making sure that everything works in the long run. So I am going to now flip over to the light dimmer. Alright, so next, this microcontroller has a light sensor right here. Hang on, let me... The light sensor. So what this screen also has is the ability to change the brightness via a pin here. So one of these pins here allows me to change the brightness by sending a PWM signal to the screen. So I have here the code that the ALS, which is the light sensor, I have the analog conversion code right here for the light sensor. So I'm going to try and implement that into, into the project, into the whole system. So plug it in, detect, next, getting started. Let's just do an empty project and we'll call it light dimmer create. And then, just like with the touch of the screen, I will connect the power, and then I'll connect one pin or one wire then from the microcontroller to the screen, and then I will control the brightness that way. So, like normal, it usually takes some time here to do this, so I will be right back. Okay, here I am again with everything. Now, so this is my light dimmer code. So essentially what I did for this was I went into the default, so this demo code here. I went into here because in here this talks about the ALS. So if I search for ALS, that does not help me. Okay. I know that at the end here I have this LED control. Function name LED control. Okay, so here this changes based upon the ambient light sensor. So this thing right here, which I've shown you before, and what I decided to do was, instead of reinventing the wheel, which I wanted to do, but unfortunately would be too complicated to just backtrace given the limited amount of time I actually have to do this and actually understand everything and make sure it works correctly, I decided to copy paste the relevant code in this main here and put it into my own main. So here I initialize the PWM signal. I begin the analog reading, and then I depend on the analog signal to give me something for the light on this LCD screen, which determines the brightness. Now right now I haven't programmed it. If I go to light dimmer and then I debug it, I spent a lot of time having to deal with errors and setting things up here because you see all of these names here, all of these like start single, no, not that one, but this PWM0 here and this config. Well, in order to actually do those things, I couldn't just copy and paste everything. What I had to do was, first things first, of course, select the project, go to quick panel here, refresh, and then I had to go to device configurator. So bring up this configurator. So I had to enable the ADC here, the PWM here, cap sense, go to the pins section, and then I had to see what I had to do from here. So I also had this, so I had all sorts of pins that I need to check out, worry about dealing with. And then once I actually did that, I went to the code preview after I would say, select the pin, and then everything comes up here. And then once everything is set up and you name it here, like if I just named it that and set enter, then it's going to change everything here in the code. So if I just undid all that, and then you save it, and then it changes the source code. So now, when I actually go back to here, this is where everything gets changed. So in the board support package here, this is where things get updated based on what I do with the device configurator. Now, I do believe I might have actually not put on... Oh, I did, okay. So right now I have a PWM pin going out of J24 here, going into the light pin. So the brighter it is, the brighter the screen is, and when I cover, it dims then the screen. So it is sending a PWM based off of the light that the sensor's reading. So I'm covering the signal right now. So of course the screen is getting dimmer based off of the light that I have coming into the sensor. And I know it's not very easy to see, but let me see if I can... You can see it better now that I'm covering it better. So it's good for reading the ambient light and then changing the PWM that's going to the screen. So simple, pretty neat little thing. Well, everything that I can do is now done. So what's the end result here? Well, this microcontroller, I don't know. I can't tell you if it's just the microcontroller. I can't really tell you if it's the software. But I can tell you that for my first Infineon microcontroller experience, I'm not really impressed. The microcontroller just seems to be bugging out a lot with some of the sensors. The design of it is oddly I'm afraid I'm gonna break it at any point given the bonds that between the controller and the sensors. And I don't like the microcontroller itself. It's good for what it needs to do, but I mean, it's just a microcontroller with a bunch more analog inputs. I mean, I could use any other microcontroller that has analog inputs and just use that. I mean, yeah, sure, this has sensors built onto it to do it, but is it really needed right now? It's definitely very sensitive. The capacitive sensors are very sensitive. All of the other sensors that I use to actually test out the thing do work, so they are at least capable of running what they're supposed to. Getting them up and running, of course, though, was weird because I had to download something to actually program the board because everything is separate and I was not aware of that. You know, I would think that when I've ever downloaded another IDE for any company, all of the needed materials to program it, to test everything out, all of that information is blatantly stated. There's clean instructions, there's something that says, hey, you also need to download this and whatnot. But for this IDE, that didn't happen. You download the IDE, but you cannot program the board. You cannot use some of the features because some things just aren't downloaded with the quote-unquote full download of the IDE. So it's definitely an annoyance that you have to go through. Not one that I even knew I was going to have to go through because I was assuming everything was all packaged together. Well, this has definitely been a learning experience for me for that, and I know in the future that if I use any other Infineon products that I'm going to have to deal with this kind of running around trying to make sure that I have everything downloaded and installed. What I did not show you guys was just how many times I had to go to the community forums on Infineon's website and just ask questions because I have had so many issues trying to program the device, figuring out why I'm getting errors with just their board support packet. A lot of these big microcontroller companies have lines of code dedicated to each device they have to make it easier and hide the underlying peripherals. So you just type in one line of code instead of having to go through and type like 5 lines of code. So while it is convenient, it does take some learning to actually know what each one is doing and to know all of the variables and to know what to put in. You would imagine though that all you'd have to do is include the libraries and then everything's set. Well, no. It's more complicated than that. It's not plug and play. You can't just call the libraries and then have everything work. You cannot just try to build the code and then download it. You have extra steps. There's a lot of runaround with this code, with this microcontroller. And even on the forums I was having problems. I was having issues where I randomly got banned for absolutely no reason. I had an issue where I could not respond anymore, like my responses were being auto-deleted by the system. Infineon makes good technology. I know that they do, because I've used some Infineon products before, and I never really had any problems with them. Granted, of course, that they weren't actually microcontrollers or anything like that. They were just other ICs. And those ICs worked perfectly. I had no issues issues with those. But I also coded them using the microcontroller I'm familiar with. Now, I could say it's just I'm not aware of Infineon's schemes and all that stuff, but it seems more runaround than I've ever had to deal with before. I have used several different microcontrollers, several different FPGAs, but for those, all I had to do was download one IDE and then everything was there. Everything was included that I needed. I mean, sure, for TI, their TivaWare is a separate package that you need to download and install, but that part isn't too horrible. And, well, I never really found any instructions. I was still capable of doing it eventually. But now I'm having all sorts of issues with Infineon. The microcontroller is just a microcontroller to me. It's nothing really special. It has plenty of analog ports, which I do say is quite nice. I do like that it has a bunch of analog ports and it has sensors built onto it for light and capacitive touch and everything, and a nice expansion header. But while it's a good setup overall, there's so many hoops to jump through that I just cannot recommend this microcontroller. I cannot recommend Infineon software because there's just so many things that you need to do to fix it, to change it, to make it work. I mean, if you have a choice, I would say don't choose this. If you need more analog inputs and you're willing to put in extra work and you've dealt with this before and you know that this is something you're going to be having to do, so you expect it, then there's absolutely no reason why you can't do this. But for me, somebody who's never used an Infineon microcontroller before, this is really not how I want to start off my relationship with them. You know, I'd rather be able to just plug and play with the IDE instead of having to jump through all these hoops just to get something to work. So overall, I would say my entire experience with this entire system, I would say, is a solid 5 out of 10. That's going to be my honest reaction, my honest feedback here. It's a good 5 out of 10. The software and everything you can do with it, there are a lot of benefits that it has. It does a lot of extra things. It has some nice interactive parts, but just being able to get it to work to begin with, that's where there needs to be a lot of work. It shines when it does work, but getting it to work is just a problem. That is my review. Thank you for watching this review of the RoadTest that I have been doing for Element 14 for the Infineon PSoC 4100T. Take this as you will. Do with this as you will. Please go out and make your own decisions if you'd like to. This video is not truly sponsored in the way of you get a discount if you buy the system, but it is sponsored in the way of I was sent this equipment for free to test out and give my honest opinion, which I am doing. So whatever you want to do next, that's up to you. Thank you very much for watching this video and my review. I do appreciate it. And Infineon, if you are watching this video, this is not my way of saying you're horrible, you need a lot of work, you should just do other things. Absolutely not. You have a lot of great things. You have a lot of great technology here. I would just want your user accessibility and user interaction to be much more evolved. I want it to be easier. I want it to be nicer. I don't want to have to struggle just to be able to program my microcontroller. I don't want to have to learn that I have to download other things in order to get something to happen. I don't want to have to dig through the mud just to find a clean patch of dirt. So Infineon, I like what you're doing. Just please make it more user accessible. Thank you very much.